Hello, I'm Professor Rad, and today we're going to talk about performing operations with numbers that are in mixed formats. So maybe you have some fractions, some decimals, some mixed numbers, as well as implied answer formats. Now, for our class in particular, when you are performing computations using different types of numbers, you'll always be able to use your calculator. But if you're not in my class, your teacher might have some different requirements for you, so just make sure you check in with them. Generally speaking, if you have mixed number types, so if you have a mixture of fractions, decimals, or mixed numbers, you'll usually want to convert the numbers into the same type before you do anything. So we've seen that so far when we've had whole numbers and fractions, we put that whole number over 1 so that we get a fraction so that we can use our fraction techniques. So that's usually helpful if you have different types of numbers. Broadly speaking, if I have fractions anywhere in a problem, I usually like to keep things in fraction format. So my personal preference is to turn mixed numbers into improper fractions and decimals into fractions and use my fraction technique. The reason that decimals don't always work well is because sometimes you'll get a decimal that has like a repeating decimal if you convert the fraction. So if you have like 1/3, that's going to give you 0.3 repeating, and that's going to make the computation a little bit more difficult. Whereas if you keep things in fraction form, it'll be a little bit cleaner and less likely to make rounding mistakes. So I did also want to point out that sometimes how a question is worded, it can imply how the teacher or the test or whatever wants you to give an answer. So for example, if you see something that says, express your answer in exact form, or this might be in simplest and exact form, or exact simplest form. If you see this phrasing where they want like an exact answer, that means that you probably should use a fraction or a mixed number. You don't have to if the decimal answer is like nice. So let me show you what I mean by that. So let's say I did a bunch of work and I got, for my final step, 21 divided by 13. So in this case, this is not a nice decimal. I notice that it's got some repeating or like some weird elements or might be repeating. In this case, I'm not familiar enough with 13ths to know if this is going to repeat the 615 back over here or if it's going to be different. So in this case, this is an instance where using a fraction or mixed number would be more likely to give you an exact answer. Because even if I wrote down all the digits that are on the calculator, that doesn't necessarily mean that, in fact, it often means that it's not exact. It means I'm rounding to wherever my calculator rounded. So using a decimal when you see the word exact form is pretty dangerous. However, if in the directions for a problem you see something that says round to the nearest hundredth or round to the nearest tenth, that means that your answer should be a decimal. That means you don't want a fraction or mixed number answer. You don't want it to be precise. You want a rounded value. And sometimes this is because of the context of a problem. So for example, let's come back to this one here. Let's say this problem that I was working on was money, right? And I wanted to know like how much I'd have to pay for a tax. Well, in that case, I'm not going to pay $1.615384615. I'm going to pay $1.62, right? I would round this to the nearest cent to get that amount of money. So sometimes when a question asks you to round to the nearest place, it's because it just makes more sense for the context, or maybe because the decimals will help you compare things in the future, or for whatever reason. So keep an eye out for these different types of language to know how to give an answer when you have a mixture of number types. So let's look at two examples here. Example 18a says to determine 5 and 2/33 minus 7.6 times 5 minus 8. They want us to give an exact answer. So that means they don't want us to round our answer or, they don't want us to round our answer. So chances are this is going to be probably a gnarly decimal, but let's find out. So I've got my calculator here, and I'm just going to type this in. So I'm going to use my mixed number button and type in 5 and 2/33 minus 7.6 times 5 minus 8. Now, again, if I were doing this by hand, I would probably change the 5 and 2/33 into an improper fraction, and I'd probably put 7.6 in fraction form as well. But my calculator is going to work with this just fine. And now notice that my calculator is giving me a decimal answer. So I'm going to change this into fraction format. Okay, and it gives me a mixed number of 27 and 142 over 165. So that's my answer in an exact format. Now, truth be told, this decimal isn't the worst kind of decimal. I can recognize that it's going to be a repeating decimal because we've got 60, 60, 60, and so on. So if I wanted to give an exact decimal, I could. 27.860 with the line over the 6 and the 0, since the 6 and the 0 are the digits that are repeating. So if I'm giving an exact answer, either of these or a improper fraction would be okay. Let's see if this calculator will do that for me, just so we can see an alternate format. So if I want to change this to an improper fraction, let's go ahead and do that. Yeah, and it'll do that for us. So we've got 4,597 over 165. So if I asked for an exact answer, any of these three would be okay. This one is probably the most dangerous format, especially if I couldn't tell if it was repeating or not. All right, let's go ahead and work through this next one. So this one says, let's find all of this to the nearest thousandth. Okay, so let's go ahead and find that to the nearest thousandth. So we've got 0.875 times 2 1/4 plus 3 divided by 7/2. Press enter, and here it's giving me a nice long decimal. So in this case, actually, this would not be a nice decimal if it asked me for the exact answer, right? It just sort of goes on, and I can't tell if it's going to repeat or not. But that's okay. It wants to the nearest thousandth. Yes, the nearest thousandth. So I'm going to use my decimal point as my guide. And as I move to the right, I've got tenths, hundredths, thousandths. So the 5 is in the thousandths place. The 8 is bigger than 5, so this 5 is going to turn into a 6. So we'll get 2.826 for our answer. So again, because they asked us to give our answer to the nearest thousandth, we are specifically not giving this entire thing. We're just rounding our answer to the indicated place value. All right, so here we go. We've got a couple of now you try problems for you to work out on your own and see how you do. Make sure to follow the directions about how it tells you to round or if it's telling you to give an exact answer. In the next video, we are going to start in on our final unit that starts with Chapter 7. And now that we've explored the different types of numbers and how operations work with them, we're going to begin applying them to a variety of different applications, different types of problems. So, looking forward to working with you on that. In the meantime, may you have an easier time speaking than I am today. Have a good day, everybody.